January 24th. Researchers are beginning to understand why the Mediterranean is disaster-prone. As new research revealed, the history of earthquakes in the region can be explained by the ongoing activity of the subduction boundary between the Eurasian and African plates off the coast of southern Italy. Until recently, scientists have struggled to pinpoint the source of tectonic activity in the region. Quote, "Unfortunately, the tectonic situation is very complicated since there are many different fault zones in this area," Heidrun Kopp, a geophysicist at the Helmholtz Center for Ocean Research, explained in a news release. "This makes an exact hazard analysis for certain areas very difficult," end quote. But thanks to a series of research expeditions over the last decade, researchers now have a much improved understanding of the region's fault system. The most important revelations have been provided by seafloor surveys off the coast of Sicily and Calabria conducted by researchers aboard German research vessel Meteor. Quote, "From historical natural disasters, we know about the geological processes in this area, but so far, the causes have not been well known," Kopp said. "Now we are beginning to understand them better." They're now beginning to understand them better. In a new paper published this week in the Journal of Earth and Planetary Sciences, Letters, a team of researchers from across Europe summarized the findings of the Meteor expeditions. They just came out this week now. Just this week. New seismic technologies allowed researchers to image the structure of the sea floor. Seismic imaging allowed researchers to penetrate 18 miles beneath the surface of the ocean floor. The findings suggest the subduction zone between the Eurasian and African plates remains active. Quote, "Of course, with the new findings, we cannot predict if and when a severe earthquake will occur," end quote, Kopp concluded. "But the more we know about the seafloor and its structure in detail, the better we can estimate where the probability of natural hazards is particularly high. Then, actions for hazard mitigation and building regulations can reduce the risks." So, using new technology, penetrating deep down into the crust, 18 miles. 18 miles. Well, guys, guess what they're using to do that? They're using something called Earth Penetrating Tomography, which is using VLF, very low frequency, to penetrate down into the crust. It reflects off almost like radar does looking at the storm clouds far away up in the atmosphere using high frequency. So using low frequency, it'll penetrate down into the crust, bounce off, come back, give them an image, quote unquote, of what's down below. And that's what they're doing. But I find it highly, highly ironic because now that we've read this article, we're going to go over to earthquake.usgs.gov, and I'm going to take you over to their plate boundary map that I've brought up every night for the last several months